and a privilege to be able to introduce you to a role model of note, a man of distinction, Mr. Sanjay Vargeshe. Mr. Sanjay Vargeshe is presently Chief Operating Officer, India Solar Farm Business at Lanco Solar, a subsidiary of Lanco Infratech Limited. Lanco Solar produces the largest solar power project pipelines in the country. The company plans to set up 500 megawatt solar power plants over the next few years and emerge as a leading developer and EPC in the country and globally. Lanco Solar has also set up India's first integrated solar PV manufacturing special economic zone project in Rajnandgaon district of Chhattisgarh to support the growing solar power industry in India. Mr. Vargeshe has been instrumental in architecting the company's go-to-market strategy in solar business in India. He is responsible for solar farms business in India. He has over 18 years of rich industrial experience, so now you can imagine how much you can learn from him. Prior to joining Lanco Solar, he was for 14 years with Impact Merchant Banking Services Limited as Vice President. Mr. Vargeshe holds Bachelor Degrees in Technology, Metallurgical Engineering from IIT Kanpur and PGDM from IIM Ahmedabad. Mr. Sanjay is also an active member of FICCI Solar Energy Task Force. So let's welcome him.
Good afternoon, everybody, once again. Sorry for the delay in keeping you waiting on Sunday. So, give you a brief background. We started the solar business in Lanco about 3 years ago, 2008. One of the first employees in the solar field. And we have a very large vision as far as solar is concerned. And we think it's a future that probably in the next 5 years is going to be bigger than even the mentioned past. And we have clear goal that we want to be one of the largest in the country and probably one of the top 5 players in the world. Okay. And try to give a brief background on how that's going to happen. One more thing I wanted to say. Public speaking is not really my style. Okay. So I would like this session to be as interactive as possible. If anybody has any questions at any time, at any point, please feel free to interrupt. Just starting about the group. Lanco Group as a whole has been the power sector for the last 30 years. In fact, we built and won the first independent power producing plant, first IPP plant in the country. This is a gas plant of 316 megawatt in Vadapalli, Andhra Pradesh. This plant was commissioned in 2003 and that was the first plant commissioned. Since then, we have added 6 plants in Delhi. We have total operating capacity of 3,300 megawatts across coal, gas, hydro, wind, and of course solar. Yeah. So while the group was involved in power, it's also involved in EPC, because we do turnkey EPC of our power plants, which is engineering, procurement, and construction. So all our power plants are built by our in-house team, EPC team. We have over 7,000 employees, and so no, this is fine. And revenues over 10,000 crores last year. Okay. So these are the 5 main sectors on which we are focused. One is, of course, owning and operating power plants as a developer. We do EPC of our own power plants, and plus we do for third-party developers also. Like we're building a power plant for Margenco, we're building one for Mozambique. Then, of course, solar is a growing business for us. Resources, you may have heard about the Griffin coal mine that we bought in Australia last year. We won the Mahatma project recently, 2 months ago, which involves development of the coal mine in Chhattisgarh. And infrastructure. Infrastructure, we're basically involved in roads, airports, small airports, ports, etc. This is a spread, as you can see, we're present across the country with projects in Chhattisgarh, Uttar Pradesh, Andhra Pradesh, Tamil Nadu, hydro projects in the eastern part of the country, and solar projects mostly now coming up in the western part of the country, that's Gujarat and Rajasthan. Let's come to the solar business now. What we are looking to do is to be a fully integrated manufacturer and developer and producer of power. Okay, so we are starting very upstream, right from what is called polysilicon, which is the basic raw material which goes into both solar cells and also the semiconductor industry. Now, polysilicon is the purest man-made material on Earth. It's a high technology product. Basically, you get silicon which is 99.99 up to 9 nines pure. Okay. So this is a process which was developed. The process which is commonly used was developed by Siemens way back in the 80s. It was under patent protection till about 2006, 2007. And there were only about 3 or 4 major manufacturers in the world which are producing this product. Since then, after it's come out of patent, there are a lot of companies which are providing this technology. We have tied up with a company called GT Solar from the US. So now the few plants which are coming up, ours is probably the only plant which is coming up in India. Though a few others have declared their plants, but they're not started yet. There are about 15-20 plants which have come up in China. And so now we are seeing that this product is becoming more widely available. After polysilicon, we move on to what's called making silicon ingots, which is melting the silicon, making it into bricks. From where you slice it into wafers. Till here, the process is common for both semiconductor and the solar industry. Okay. These silicon wafers then go into making either your silicon chips or they go into making solar cells. Then you come to making solar cells, which is basically converting the wafer into a cell which can generate and store the electricity. Then you come to the modules, or what's known as your photovoltaic panels. Then of course, as a developer, we are developing power plants, we're building power plants, into which our panels will go. For building these power plants, we have our own internal EPC team. We do the engineering, procurement, and the construction. And then we move into the world of the power plants. Typical life of a solar power plant is 25 to 35 years. So that's the period for which you need to maintain this plant. Now, what we have seen in this industry over the last, say, 8 years. 2003 was when the industry really started taking off. This was when Germany came out with their first feed-in tariff, which was at that time 60 euro cents a unit of power, which is you're talking about 35 rupees a unit. Okay. And that was when the industry really started taking off, because Germany came up with this target that they want all energy which is used in the country to be, not all energy, 20% of all energy to be used in the country to be from renewables. So they came out with this target. They had a plan to phase out all the nuclear plants, phase out their thermal power plants, and gradually shift to renewable energy. So Germany is the largest market in the world today for solar. Okay. So if you see potential-wise, if you see the sunlight that they receive, they are probably one of the worst countries in the world. But they have been very keen on renewables, and so last year the market worldwide for solar was about 17 gigawatts, 17,000 megawatts, and about 7.5 gigawatts was in Germany. Anyway, so what you've seen in this market, as I said, is from 2003 onwards. If you see, the average growth rate in the market was more than 50% a year. Okay, in some years it grows by 100%, some years by 20%, but the average is more than 50%. And so what we always saw in this market over the last 8 years is that at different parts of the value chain, you get these problems of demand and supply shortages or mismatches. Okay, so you had prices moving widely for various parts. Some year polysilicon will be very expensive, some year maybe wafers will be more expensive. So, which is why we decided that we want to be fully integrated. Because we don't want to be dependent on anybody for our supplies. Okay, we want to have control of the costs, and that we believe is going to be the way to lead the market going forward. So, what are we doing in manufacturing? So, as Mansha mentioned, we are setting up this SEZ in Chhattisgarh, which is the first fully integrated SEZ probably in the world. Okay, because there's nobody in the world who's actually producing everything from poly going up to modules. Okay, so we have this 1250 metric ton polysilicon plant which is under construction, which will be commissioned by September next year. And we have an 80 megawatt wafering facility that we are setting up today. Okay, so the first two stages of the value chain have been covered now. We have also set up a 50 megawatt module plant, which is the fourth stage of the value chain that we saw. So this module facility is already in operation since May, and it is currently manufacturing at 4 megawatts a month. Okay. And the cell plant is something that we are waiting because the technology is changing at a very rapid pace. Cell efficiencies, I don't know how familiar you are with the term of efficiency, but cell efficiencies have gone up from something like 14% to 17% in the last 2 years. And we expect it to go up to about 20% within the next maybe year and a half. Okay. So we're just waiting for the technology to stabilize. That's when we'll step into that stage of the value chain. Now regarding solar farms. So we have pipeline in solar PV of we have 35 megawatt PPA in Gujarat under the state policy, of which the first 5 megawatt is commissioned in January this year. Okay. The second, we expect to commission another about 9 megawatts within the next week or 10 days, and the balance capacity will get done before December. We have the 1 megawatt plant under, if you are aware of the RIDA scheme, which had come out where they had selected about 100 developers to build 1 megawatt plants across the country. So we have one plant under that in Rajasthan, which has actually been commissioned last month. It was commissioned on September 29th. Okay. September 16th. Then also under the National Solar Mission, we have a 100 megawatt solar thermal and a 5 megawatt solar PV plant, both coming in Rajasthan. We have done an 80 kilowatt rooftop project from the Indian Parliament House. We are building a 1 megawatt project for the PEDAS, for the Punjab Energy Development Agency, Science City Chandigarh. So we have few projects across the country. Now, other than this, we are also doing third-party EPC, which means we are building the power plants for other developers. So we are building a 75 megawatt solar PV project in Maharashtra for Mahagenco. Okay. And we are doing additional about 140 megawatts for various developers both in Gujarat and Rajasthan. So overall, basically in India, we have 200 megawatts of solar thermal plants which we are constructing, and about 160 megawatts or 170 megawatts of solar PV plants which we are constructing. So we are looking at about 350, 360 megawatts that we have to build over the next year and a half. Okay. We also have an international business which is headquartered out of London. Okay, we are now active in about 7 markets in Europe and US and Canada. Okay, and we have done we have commissioned a 1 megawatt project in Italy. We have done 2 projects, small projects of 200 kilowatt each in France. We have done 2 small projects of 200 kilowatt each in the US. We have various other projects that we are working on. We have about 40 people in Europe and US currently as part of our team. Let's just come to the sector, what we see in the sector. Any questions so far? Yeah.
So what is the rationale behind you going for 100 megawatt solar thermal and only 5 megawatt for solar PV when it comes to...
No, that's again one of the rules and the guidelines of National Solar Mission. Okay. So under National Solar Mission, they want to do 1000 megawatts before 2030. Of this, they decided that 50% of the capacity would be solar thermal and 50% would be solar PV. Now for solar thermal project, they fixed the maximum size of a project at 100 megawatt. Okay, so we bid and won a 100 megawatt project. For solar PV, they had a 1 round of allocations last year where they allocated projects for about 150 megawatts, where the maximum size of the project was 5 megawatt. Okay, so we won one project under that. They have a second round of allocations which is coming up now. Okay, in fact, the first initial applications are due tomorrow. That's for 350 megawatt, and this time the maximum size of the project is increased to 20 megawatt. Okay, and with the group being able to bid up to 50 megawatts, so we would be bidding under that.
Which kind of solar plant you are in this segment?
The solar thermal parabolic cloud.
Parabolic.
Yeah.
And backed up by diesel or something?
No fossil fuels.
No backup of gas. So
what we are doing is we are going for molten salt storage. Okay, we are going for thermal storage using molten salt. So, which will allow us to store the energy for about 4 hours usage. Okay, so that will cover for your fluctuations in radiation or monsoon. So that will give us some sort of stability in the performance.
Storage in battery?
No, molten salt. Molten salt. Basically, the heat gets stored in molten salt. Okay, so you use salt. Okay. Typically how a parabolic plant works is that you have mirrors which focus the sun's light onto a tube which is carrying a thermic fluid or an oil. This oil then gets heated up to over 350 degrees centigrade. This is taken to a heat exchanger where the heated oil is used to make steam. Okay. Now when you do storage for solar thermal, the advantage is that you can use a medium like salt. Okay. Now salt is typically something which melts at about 80 degrees or not 80, probably slightly more than 100, but it vaporizes only at about 400 degrees. So up to about 350 degrees centigrade, you can easily store the energy in salt itself. Okay. So what we do is, instead of taking the thermic fluid or the oil to a heat exchanger to make steam, we take it to another heat exchanger where we store the energy in molten salt. And there the energy can be stored overnight if it's kept in a well insulated container. And the next day morning you can use the energy from the molten salt to make steam. Okay. Or you can also use it to produce electricity during the evening when your sunlight is not available. Okay, you can then pass the water through the molten salt container through a heat exchanger and take the heat from the molten salt and generate electricity. I'll just come to parabolic clock in a minute. So just looking at the market as a whole, we see the various renewable applications. The first graph gives you the annual growth rates. If you see, solar PV grid connected has grown at an average of about 60% over the last, over the 5-year period from 2005 to 2010. And solar PV as a whole has grown at about 50%, which means both grid connected and off-grid applications put together. It's much larger, growing at a much faster rate than any of the other applications like wind or hydro or geothermal, etc. Okay. The wind market, solar PV is where the wind was probably about 6 years ago. Okay, wind market is going at about 30-40 gigawatts a year now. Solar PV, solar as a whole is at about 18 gigawatts. Last year was 18. This year would be about 22 is what we expect. Okay, and we should be catching up with wind sometime in the next 2 to 3 years probably. Yeah. So that's the top graph gives you the growth rates. Now the bottom left-hand side graph gives you the major markets for the various sources of renewable energy. So anyway, we'll be sharing the presentation with you, so you can study this in detail later. So typically, this is a comparison of the potential for various renewable energy sources in India. Wind, you can see, is about maybe about 50 gigawatts is the potential that exists. So, the installed capacity is about 14 gigawatts. Small hydro is about 15 gigawatts. Installed is about 3 gigawatts. Biomass is about 25 gigawatts. The installed capacity is about 2 gigawatts. Solar PV is probably about infinite potential because you can put it up anywhere that you get sun. So, and the installed capacity is only 45 megawatts. Key reason why there's such a large potential but very low usage is, of course, the cost. Okay, cost-wise, it has been much more expensive than any other source of energy. Now, 14.4 to 15.5, 14.4 if you see is the cost that CERC determined last year for solar PV power plants. But today, if prices have come down even further, it should be possible to set up a solar PV power plant just pure cost between 10 to 11 crores per megawatt. O&M-wise, there's very minimum O&M that has to be done in a solar plant. Okay, it's basically you're cleaning your panels, making sure your connections are okay, etc. PLF-wise, solar will typically give you about 18 to 19% PLF, whereas with trackers, with using newer technologies, you can improve this to about 23, 24, even 25%. So issue all this translates into a much higher cost for solar, which is about 15.3 times the tariff that CERC determined last year, whereas wind is hardly at 3.5 rupees. Okay, and small hydro is probably cheaper, biomass is slightly more expensive. But while the other renewable energy sources are now very close to conventional electricity prices, which is coal and gas, and a position to compete with them, solar is still not in the same position, but we'll get there in the next 4 to 5 years is what we expect. So why we feel India today, as we saw last year, was only 45 megawatts, whereas the world market was 17,000 megawatts. Okay, so we are a minuscule portion of the entire market. But we feel that with the National Solar Mission, which is brought in, which says targets 20,000 megawatts by 2022, plus the fact that we have so much potential for solar in the country, plus the fact that we have shortage of electricity, that we are dependent on imported sources for most of our energy needs, whether it's oil or gas. So we expect that solar is going to have a very major role to play here, and that next 6 to 7 years we're going to be one of the largest markets in the world for solar. this is the national solar mission, what was announced, what I was talking about. Basically, we are targeting 20 gigawatts by 2022. This is divided into 3 phases. So phase 1, the target is 1000 megawatts by 2030. Okay, which is what I was talking about. The bidding that has happened for solar thermal 500 megawatts is over. Solar PV 150 megawatts of allocations is over. Another 350 megawatts will get allocated by January. In the second phase, they are looking at anywhere between 3 to 9 gigawatts. 3,000 to 9,000 megawatts is the target. And the third phase, the balance capacity, which is required to reach 20 gigawatts, is expected between 2017 to 2022. Now, the expectation is that the government support is definitely required in the first phase. Some sort of government support would be required for second phase because solar will still be expensive. But by 2017, the government expects the solar will be on par with coal power or gas power, gas-based power in terms of cost. So after that, you will see a major growth in the market because you have grid parity and the solar is able to stand on its own without any government support. Now, how will government drive this market and make these targets happen? So 2 ways. One is to give subsidies. So for example, the phase 1, what they're doing is that they're bundling solar power with cheap unallocated electricity power which is available with NTPC. Okay. This power is typically costing about 2 rupees a unit. So you're taking 11, 12 rupees power, bundling it 2 rupees power, the ratio 4:1, and then selling it to utilities across the country. So they appointed MVVN, which is a subsidiary of NTPC, a nodal agency for this. Okay. So this agency is buying the power from solar developers, bundling it to its NTPC power and selling it to the utilities at average cost of about 4.5 rupees. Okay. So that is the form of subsidy that's being given now. But going forward, obviously government can't keep subsidizing for 2,000, 3,000, 4,000 megawatts. So what they are proposing to do is they're bringing in what is known as a renewable portfolio obligation for solar across all states. So the CRC and the Forum of Regulators across various states have been driving this process. About, I think, 19 states have already, state regulators have already declared the solar RPO obligation, which is ranging from 0.1 to 0.25% of all energy consumed in the state, which means it mandates the utilities to purchase solar to the extent of 0.1 to 0.25% of the consumption, varying from state to state. Now, the target which is given under the solar mission was 0.25% by 2030. Now, if you take 0.25% obligation itself, the requirement to meet the RPO across various states, depending on how the electricity growth rates will be, etc., is projected to be almost 2,000 megawatts against the 1,000 megawatt target which is there under the RSM for phase 1. And if you go to 2022, this requirement, RPO obligation, is expected to grow between 2013 to 2022 at 0.25% per year. So it means from 0.25% in 2013, it will go to 3% in 2022. And that 3% requirement, projecting your electricity growth, etc., electricity consumption growth, would be close to about 40,000 megawatts. Any questions?
Sir, at what PLF plant load?
This assumes a PLF of 19% for solar, and your typical thermal PLF would be around 80%. The RPO itself is not declared on megawatt capacity. It is declared on energy consumed. So utilities buy energy from various generating power plants. Whatever energy they buy, of that a certain percentage they have to buy from solar. And if they don't buy that energy, they have penalty, which is equal to the tariff which is declared for solar by the state regulator. So if it's 15 rupee tariff, if you don't buy the solar energy, then you have to pay a penalty of 15 rupees per unit. Yeah.
So like, as you were saying, government cannot give subsidies once it reaches to megawatt level, 1000 megawatt or 2000 megawatt.
Correct.
So if we look at the Spanish market scenario, in the Spanish market, like once the subsidies were not given, like then the whole market has collapsed. Like there were no developers coming.
Absolutely.
New capacity addition was not there in renewable.
Okay.
So what if such a case happens in India?
Which is why they have this RPO mechanism. Okay. Which is so it's basically a carrot and stick approach. So one side you have a carrot of subsidies to a certain extent. Okay. Beyond that, then you have the stick, which says that you have to consume certain amount of energy from solar, otherwise you pay a penalty. Okay, so that's how. So basically, the utilities which are buying power from various developers and selling them to the consumers, we are the ones who will have to meet this RPO obligation. That's one part. Second part is coming back to the Spanish market. Spanish market, what happened was that in 2008 was the year in which the Spanish market suddenly came out of nowhere and grew. Overnight, you had a 3 gigawatt market. So 2007, I think there were 400 megawatts. and 2008 they were 2.8 gigawatts. Now what happened there, what went wrong there was that they came out with a tariff of about 42 cents, euro cents, which is 30 rupees a unit. And when they came out with the tariff, I don't think there was too much thought in the process. They came out with the same tariff that Germany had. Now problem is Germany receives only about 2/3 of the sunshine that Spain receives. Now with the same tariff that Germany had, suddenly Spain became much more profitable than Germany. Okay. Developers were making a lot more returns and they had no capacity cap. So suddenly everybody rushed into Spain and put about 3 gigawatts capacity in a single year. And then they found out that they couldn't pay so much money for so much of power, the subsidies. So then from the next year onward they came out with a cap of 500 megawatts per year. And then they have an application process which is fairly long, so even the 500 megawatt doesn't come up, which is what happened with the Spanish market. So suddenly 1 year it was 3 gigawatt, next year it became 300 megawatts. But India, we are basically starting with caps right from the beginning. So we're not going to have uncontrolled growth of the market until the parity is reached. So coming to technologies which are normally used. Okay, the most common and the most prevalent is what's called crystalline silicon, which is what we are going to manufacture. What we are manufacturing, panels that we are manufacturing, the polysilicon that we manufacture, the wafer process, the cells, etc. goes into what's called crystalline silicon technology, which is basically make your polysilicon, make your silicon wafers, your cells, then your modules. Another technology which has also been there for a long time, but which is not very popular, it's called amorphous silicon. The advantage with this technology is that silicon is converted to vapor form and then deposited on glass panels. Okay. So your typical silicon vapor is about 180 to 200 microns thick, is the size of the silicon vapor. Whereas in the case of amorphous silicon, the layer of silicon which is deposited on the glass is only about 3 microns. Okay. So you end up using a lot less material in the manufacture of this panel than you use in the case of crystalline silicon. And silicon is a very expensive material. Okay. And this technology suddenly took off in 2007 when there was a shortage of polysilicon. So 2007 was the year, and 2008, if you see, the market was about 5.5 gigawatts, which grew from what was about 2 gigawatts, so it more than doubled in that year. And polysilicon, as I mentioned at that time, was just coming out of patent protection, and there were very few manufacturers. In fact, the entire 90% of the global market was probably controlled by 3 people. One is Wacker in Germany. The other is the Dow Chemicals Group in the US. It's a company called Hemlock. And the third was a player called REC in Norway. And because they controlled the market and the product was in short supply, and so you had polysilicon prices going up from what was really $30 a kg in 2003 to $400 a kg in 2007. And then there was a huge shortage for this product. So then people started moving to technologies where you use less of silicon material. Okay. And that's when amorphous silicon picked up. Of course, things have changed over the last 3 years. Polysilicon there are more manufacturers come in. In fact, there's a manufacturer in Korea called OCL, who's probably as big as any of the other 3 major players today. There are a couple of manufacturers in China which are producing about 30 to 20,000 tons a year. So the new manufacturers come in, the product is more readily available. So prices have again come down. Currently, it's at about $50 a kg. Okay. And with prices coming down, people have now, the fad which was there for the alternate thin film has sort of come down. Amorphous silicon is not getting used so much these days, and suddenly people are now switching back to crystalline. Okay. The third material is called cadmium telluride. Now, cadmium telluride is almost entirely manufactured by a company called First Solar in the US, which is one of the largest solar players in the world today. Okay. The advantage of cadmium telluride, it's also a thin film technology, is that First Solar has a proprietary technology by which they are able to manufacture this at a cost which is probably about 60 to 70% of what it would cost to manufacture silicon panel. Okay. So they have fairly large leadership position in the market. Only problem is that they don't share this technology very easily. So all the manufacturing, the technology is with them, and they set up their own plants. Most of the plants are Malaysia and Philippines. They're setting up a plant in Germany and a plant in the US. So they have about 2 gigawatts of capacity. So to that extent, they are able to sell that. So about 10% of the world market share is probably with them because of the price advantage that this product has. Fourth is copper indium gallium selenide. Is a product which in lab tests has shown to be more efficient than any of the other thin film technologies. In fact, you probably can have efficiencies which will get close to crystalline silicon. So it's a product of the future, not yet commercially established. There are no large players in the world today, but going forward, we expect this to play a major role. So, India, the way policy has developed, there has been the government is trying to encourage domestic manufacturing while they are giving these subsidies for solar. So, in the first phase, when the first 150 megawatts of projects were bid out for solar PV, the government mandated that all modules which are used, if they are crystalline silicon, should be made in India. Whereas if people use thin film technology, they were allowed to import. This is because we had only one thin film manufacturer in India. Mozambique has a 40 megawatt plant in Noida, which is manufacturing thin film. But other than that, for crystalline silicon, you have about 700-800 megawatt of manufacturing capacity. Okay, so the government said if it is crystalline, you use manufactured in India modules. If it is thin film, you can import. Plus, thin film has the advantage that it has a lower what's called temperature coefficient. Now, typically, when you see the capacity of a panel, if you say it's a 200 watt peak panel, which means that it's supposed to generate 200 watts of energy under ideal conditions, which means if it receives ideal sunlight at ideal temperature, ideal atmospheric conditions, it will generate that capacity. Okay. But typical conditions out in the field are not ideal. You would have sunlight which is probably lower than what is ideal, or sometimes it can be higher also. The ideal temperature, ideal sunlight is defined as basically 1000 watts of energy per meter square of area. Okay, that's called the standard condition. Out in Gujarat and Rajasthan, we have sometimes found the actual radiation to exceed that number. Okay. Plus, the main problem that happens is temperature. So, the temperature standard condition is treated as 25 degrees centigrade. Okay, that's what level with the capacity is measured. And typically, your temperatures out in the field would be 40-45 degrees centigrade. And the panels itself will heat up to about 55, 60, 65 degrees centigrade. Okay, under 45 degree ambient conditions. So what happens if every degree rise in temperature, the efficiency of the material, the silicon material goes down. Okay. So your typical silicon panel has a temperature coefficient of what's called about 0.4, which means for every 1 degree rise in temperature, the wattage or the energy that it can generate goes down by 0.4%. Okay. Whereas for thin film, typically that coefficient is about 0.2. Okay. So if your temperature is about 20 degrees above normal 25 degrees, then your thin film panel will generate about 4% extra energy because of this 0.2% difference in coefficient. So with 30 degrees above normal, it will be 6%. So typically under Indian conditions, your thin film panel should generate about 4 to 6% extra energy is what we need. Because of this reason and because of the policies, which says that if it's crystalline, it has to be manufactured in India. If it is thin film, it can be imported. We see thin film actually having a larger market share in India than it will have in the rest of the parts of the world. So worldwide, about 85% of the market is crystalline, 15% is thin film, of which, as I said, 10% comes for solar. Whereas in India, it may be closer to about 60-40 or even 50-50. But as far as we are concerned, we are convinced that crystalline is the product of the future, primarily because of the difference in efficiencies. I will come to that when I come to the costing part slightly later. So which is why we are focused on this slide. But a lot of developers who are not in the manufacturing space or do not have experience in EPCs are going for thin film. Yeah.
As Lanco is in manufacturing as well as at the plant also.
Correct.
So what is the future of increasing the efficiency of solar PV? Because as we have now only...
That's what you're mentioning. So it's about 16-17% is commercially available technology today in solar
Can we
PV.
increase in future something like 30-40%?
30-40% is very specialized products which are used for space applications. In fact, first solar initially started getting used for space applications. Basically, you put your satellite out, you see it has those 2 wings with solar panels, which generates electricity to keep the satellite running. So when NASA developed the first solar application, they actually had efficiency of 35-40%. But they're very specialized materials and very, very expensive. The theoretically, I think the efficiency of silicon, what they say, can go up to about 25-26%. Okay, that's the maximum. There is a company called SunPower in the US, which is even today producing cells which are about 23% efficient. Okay. Yeah. Now, how they do this is they have a different technology, and the number of steps involved in that process by which they use to make those cells. Problem is too expensive making that. Okay. So it's always a combination of cost and trade-off between cost and efficiency. Okay. So finally, what matters is cost efficiency to generate the electricity. Whether it's more efficient, less efficient, doesn't really matter. So by the normal processes, yes, today it's 70%. We expect it to hit about 19-20% by next year and a half. But maybe that's where the industry will settle. This is the technology-wise, how the market shares across various technologies for solar PV have varied. So if you see this slide, there are two different technologies in this. One is called monocrystalline and the other is called multicrystalline. Monocrystalline is a little more efficient than multicrystalline because the structure of the silicon crystals or the silicon cells in the wafer is slightly better. There's slightly higher efficiencies, slightly more expensive also. And these two, if you see, market share is almost equal, but overall this line has a market share of more than 80% and about 85% last year. So thin films are between 10 to 15%. That's okay. Cadmium telluride is the green one. If you see in 2009 it was about 9% of market share. Okay. 2010 it's taking from about 5%.
So what is ribbon?
Ribbon CSI was new technology which had come out, but the wafers were really thin. Okay. So whereas you have normally 180, 200 micron wafers, these were wafers which have 40, 50 micron, etc. It was not very popular, again very expensive, so it's sort of dropped out of the market now. This would have come up here, I think. This was the top one. Yeah, that's, if you see it is gradually shrinking. So it's more or less disappeared. So this is just looking at the value chain in a little more detail. As I was saying, the polysilicon is the key part as far as the cost is concerned. Very monopolistic market. Used to be about 3 large players earlier. Now it's about 15-20 players, of which still 8 or 9 do control about 80% of the market share. Okay, the top 8 or 9. Okay. Technology-wise, very challenging. Technology is available now, but still challenging to put up a polysilicon plant because of the high purity levels that you maintain the entire plant. So it's not easy to build and stabilize a polysilicon plant. It takes about 2.5 years. So typically what happens is suddenly 1 year the market grows very large. It is not easy for people to come and put capacities to meet that additional demand. So you will always have this problem of supply-demand mismatches. Because it takes 2.5 years to build a plant. And the market can grow by 100% in a single year, like it happened last year. So you will always have this problem of supply-demand mismatches. Wafer cells, modules, etc. it's much more easier to set up. A wafer or cell plant takes about 9 to 12 months to set up. So if you have sudden growth in the market, you will see capacities also following very soon. Now in this market what happens is like last year the market grew by 100%. So from 8 gigawatts in 2009 to 17 gigawatts in 2010. And when this market grew, so towards the end of last year we actually had prices of all the polysilicon wafers, cells, modules, etc. going up because the capacities were proving to be short. And then we had a lot of capacity addition which happened in the last quarter of last year, that is October, November, December, and the beginning of this year, which is January and February. And worldwide manufacturing capacities for downstream products actually went up from 20 gigawatts to 40 gigawatts in the span of about 6 to 7 months. And so what we have been seeing this year, from April onwards, is that prices have started crashing dramatically. And the panel prices have probably come down by about 30% in the last 6 months. Okay, so PV suddenly become a lot cheaper over the last 5 to 6 months. But polysilicon prices, which were at $55 last year, in say October, today even now at $50. Okay. So it's 40% the rest price reduction. Polysilicon is only hardly 10%. So which is why we felt it was important to be across the value chain, present everywhere. Because we don't want to get caught out in any part of the value chain because of price fluctuations. So key factors that you look for as a developer, EPC service provider in the product that you buy. Okay. Okay, in modules you're looking at efficiency, because efficiency is more important because a more efficient panel needs less land to set up. Your capital cost in terms of balance of systems, like the structures on which you put on the panels, the cables that you use to connect the panels, everything comes down. You use a more efficient panel. So thin film has an advantage of maybe the panel itself being cheaper than the multi-discrete panel. But what we find is that when you add the balance of system cost, which is the land that you require, structures, the civil work, the cables, etc., everything when you add up, the cost actually turns out to be higher than this slide. The key equipment other than the module in the plant is your inverter. Inverter is what, because every panel produces what's called DC output, and then the inverter converts into AC for feeding into the grid. Okay. Inverter typically comes with most from mainly European manufacturers dominate the market today. Typically carry warranty between 2 to 5 years. But this is a product which has to run for 20-25 years. So inverter is something that you have to choose very carefully. Inverter efficiency is also very important. Your household inverter that you use typically has an efficiency of 80%, which means that whatever energy it receives, current it receives, by the time the input-output ratio is only 80%. 20% energy gets lost in the conversion. The inverters that we use out in the field in a solar PV power plant will have typically an efficiency of 97% lower. Okay, because the energy is very expensive to lose in the conversion process. So this is coming to solar thermal. I'll just tell you briefly what is there. The four main technologies which are there in solar thermal. Solar thermal is a much smaller market than solar PV in the sense that it's about a gigawatt in size probably in terms of installed capacity, whereas PV is at 40 gigawatts plus. Total installed capacity for solar thermal across the entire world is about 1 gigawatt. Mainly in the US and Spain. US, they set up the first plants back in 1970s and 1980s out in the Mojave Desert. They have about 300 megawatts of capacity which is running there for the last more than 20 years. Okay. This happened immediately after the 1973 oil shock. When we had the effect of these increasing oil prices dramatically, they decided to pump money into solar research and then they set up these plants. And while these plants have been running very successfully, still the cost of course of solar was always been expensive. And after the oil shock died down and the oil prices came down, they stopped going into the program. In 2006 onwards, Spain started pushing solar thermal. Spain is another country in Europe which receives very good sunlight. So problem with solar thermal, unlike solar PV, is the solar PV can work even low amounts of sunlight. Solar thermal receives what is requires what is known direct normal radiation to achieve the temperatures which are required for making steam. So it can work only in countries which are very hot. So desert areas are excellent spots for solar thermal. So it has limited application as compared to, or potential as compared to solar PV. So the four main technologies are what is known as parabolic trough. Most of the plants in the world, more than 90% are running on this technology, and that is the established one which is running for the last 30 years. The other technologies are trying to improve upon this technology. This technology has a limitation in terms of cost, one part. The second part is regarding temperatures that it can achieve. You can do only 350 degrees of temperature maximum. This in turn means that you're producing steam at 350 degrees. Your supercritical thermal plants, these are producing steam at 600 degrees plus, so your turbines are much more efficient, whereas for this you require a low pressure, low temperature turbine. So efficiencies are lower. So because of that reason, these limitations. Tower is the technology which looks like the technology of the future as far as solar thermal is concerned, because tower can achieve temperatures of up to 550 degrees centigrade. Okay. Then you get much closer to conventional steam temperatures in a power plant. And so for that reason, we have about 3 plants running on tower technology today in Spain, 10-20 megawatts capacity each. But probably going forward, this will be the technology which will take over from parabolic trough. Fourth technology, linear front reflectors is similar to parabolic trough, except that instead of using curved mirrors, which focus on a tube, they use flat mirrors and a number of small mirrors to focus on a tube, on a central tube. Okay, so basically all the mirrors are inclined at different angles to create that curve effect, and then so it turns out to be cheaper because you don't have to bend the mirrors and much easier to set up. are the key elements which go into a solar thermal power plant. Again, you see in some of the elements we do have a problem of limited number of suppliers. So it means again a monopoly situation, again prices getting controlled by limited suppliers, so that has an impact on the cost coming down. So the thermic fluid or the oil which is used inside the tube to heat up, to collect the heat is produced only by two manufacturers. The tube itself, okay, it's called absorber tube which absorbs the heat, that's again the only two manufacturers in the world. Mirror assembly is again a controlled technology. Structure is also, there are few more players in that. Power block, of course, because it's a low temperature, low pressure turbine, which also faces frequent start-stop. Because every day in the evening when your sunlight is gone, it stops. Next day morning it has to start again, which is not the case with conventional turbine, which is running continuously across the year. So frequent start-stop can damage the turbine, so you need specialized turbines for this purpose. Okay. And the last item is molten salt, which is what I mentioned about storage. Okay. So the advantage, with one advantage that is there for solar thermal as compared to solar PV is that it can run as a base load plant.
So,
yeah.
What would be the per megawatt cost of solar field in case of solar tower? I mean,
solar thermal.
Solar field consisting of heliostat.
Consisting of heliostat.
Yeah, total per megawatt.
Total all put together, the solar thermal power plant would be around, say about 12 crores. Okay, and the solar field out of that would be roughly about 60%, 60-65%.
You said 12 crore per megawatt?
Yeah.
How much?
PV is now down to 11, maybe below 11. Yeah, PV used to be more expensive than thermal till last year. Now it's probably cheaper.
Really going down?
Yeah.
What is the cost today?
Today it's less than 11 now. So 10 and a half, 11 crores. Yeah.
11 crore per megawatt?
Less than that. In fact, we expect it will be below 10 by end of the year. This is expected growth rate in various markets. Basically, key markets for solar thermal are, as I said, will be in the desert region, the tropical areas. Okay, and so it's your MENA region, your Middle East, North Africa, India. Spain, of course, major market today because subsidies are bigger, but I don't think Europe or US is going to be a major market for. US will be a major market out in the desert areas, which is California and Texas and the areas around that. Yeah. California, Nevada, the areas around that would be a major market for. See, typical capacity factor for solar thermal, what we have is 23%. 3. Net of auxiliary consumption should be around 21.5%. With storage, the plant that we are putting up, we are targeting a capacity factor of 35%. Yeah. So because basically we run extra hours, a typical plant will run 6 hours, we'll be able to run for 10 hours because of 4 hours storage. So. Solar PV, what we are finding with our plant in Gujarat, which is a plain vanilla simple technology plant, is 18.5%. And the plant that we're putting up in Rajasthan, we're going with trackers. Tracker is basically a technology where you follow the sun. The panel moves according to where the sun is, so you're able to increase the output. And there, plus what we're doing also in Rajasthan is that we're putting more capacity on the DC side, which means while your inverter, your transformer, etc., the electrical switchout part, etc., everything will be for 5 megawatt. Your DC side capacity, which means your panels can be for 5.5 megawatt. Now, this is mainly to cover for the losses that you typically face in a PV plant. Now, these losses will come from, one is the temperature losses, right, on the modules, so they will produce, say, 5 or 6% less than what you're supposed to produce. Plus your losses in the inverter, which will be 2 to 3% in the conversion. Plus your losses in the cables, the DC cables, the connectors, and so typical losses in a PV plant will be somewhere between 15 to 20%. Okay. Or what it, so if your capacity is 5 megawatt, typically it will generate about 4 megawatt capacity. So there's always scope to add a little bit extra capacity on the DC side, which is the panel side. Okay. So if your inverter of 5 megawatt, you can 1 megawatt, you can typically convert about connect about 1.1 megawatt of panels to it. Okay. So that's what we are doing in Rajasthan. So policies are different. Like Gujarat doesn't allow you to connect that extra capacity, so everything has to be there. Allocating your 5 megawatt capacity, and everything has to be 5 megawatt. In Rajasthan, they're looking at only the national solar mission. They're looking at only the AC side capacity. So if the AC side everything is 5 megawatt, I can still connect 5.5 megawatt on the DC side. So which allows me to get more generation at a lower cost. So typically with that 10% extra capacity on the DC side and with the trackers, we should be hitting about 24% PLF. 24 now.
Sir,
Yeah.
Sir, in terms of cost, comparing between stable and tracking solar system PV,
Yeah.
how much difference do you get in terms of efficiency and cost?
Increase in cost, we're looking at about 10 to 12% increase in cost
And
and about 17% increase in output.
17% increase.
Yeah.
What about in solar thermal storage?
Solar thermal storage, we don't see the storage itself giving you a great advantage in terms of cost, which means the additional cost and additional output are almost the same today. Okay. Again, the problem there is that the salt is very expensive because it's controlled by again only two manufacturers. But as more suppliers come into the field, we expect that cost will come down. But the great advantage with molten salt is that, see, I'm running a plant out in the desert. If you have even a small cloud which passes over, suddenly the output will drop. Okay. So having the storage with me allows me to use that stored energy to keep the output static. So that my turbine and everything are running at proper efficiency. So that's the advantage of storage today. But going forward, it's going to be much more advantageous to use storage in terms of cost.
For 100 megawatt plus plants, why do you consider pump storage as an option?
You mean compressed air?
Pump storage plant by the side of this plant.
Compressed air.
It can be.
Compressed air, you're saying you mean the hydro type? Okay.
They are very efficient in terms of turbining and pumping. Which is very little in
But typically,
and independent of sun.
Yeah, that's fine.
You are saying one cloud comes and your salt.
no, salt doesn't get affected. My actual plant, which is without storage, will get affected because I'm not heating my temperatures on the oil. But if I have energy stored in the salt, okay, I can use that energy at this time to keep my output constant. So that is the advantage of storage. So not just gives you extra hours, but also makes the output more stable. Which is what I was saying earlier, that solar thermal can be used as a base load plant as compared to solar PV. So PV will have it, will give problems to the grid once you have a large proportion of PV because the output is going to be intermittent. So in Gujarat, if I'm setting in the western part of Gujarat, then if you have large capacity which is coming up in one area, okay, suddenly the 500 megawatts start producing, which is generally producing 450 megawatts. Suddenly it drops to 100 megawatt because of some cloud which is passing over because the weather condition turns bad. It can affect the entire grid. Okay. That problem you may not have with solar thermal with storage. Without storage, yes, you would have the same problem. And what solution you are saying probably can be worked out, provided you can find a location where both works.
Yeah, where both the.
Yeah, because you have this limitation that you need to have direct normal radiation for solar thermal. Doesn't work well in the areas where hydro works normally.
So, my question is regarding solar PV, and it's a bit different from the current slide of discussion.
Yeah.
By the end of the life cycle of the solar PV project, how do you recycle these hectares and hectares of wafers that modules that we cover?
It's actually, the panel has a small amount of vapors in it. Other than that, it has got aluminium, glass, etc. It's a big problem in terms of recycling the whole thing. Okay. Most of the plants in the world have not reached this stage. Okay. But yes, especially in Europe, we find that solar plants are becoming more friendly towards the environment and the nature. So what they are doing, in fact, in the issue is that they use a lot of agricultural land. Okay, so one of the things that they do to make sure that the recycling is not a problem is that they avoid using civil foundations for solar power plants. Okay, so typically the structure is rammed into the ground. Okay, so if you have 2 meter height above the ground, you typically have a 2 meter height below the ground. They simply ram it into the ground without using any civil foundation. That after the life of the plant, if you want to remove the whole thing, it can go back to agricultural land. Okay, so those sort of things are happening in Europe. We are in fact just in the process of procuring these ramming machines. In fact, for the Maharashtra project, we'll probably be using them. Okay, So those are the developments which are happening. Solar PV, the PV panels as such are not environmentally hazardous. Okay. So there would be a problem in terms of removing it and disposing it off somewhere, but it's not a major problem. The one problem that is there is with cadmium telluride. Now, cadmium telluride is a toxic substance. Okay, so while it is sealed within the panel, it doesn't give a problem, but disposal of that can normally be a problem. So, for example, First Solar has a commitment to every supply that it makes that it will pick up the panels so that they can be disposed of after the life of the plant. So, First Solar, as I mentioned, is the only major manufacturer cadmium telluride. So, you have environmental issues with some types of technologies, but not across. So others also, they are trying to be more environment friendly, as I said, to the way it is from the plant. These are some market sizes that we expect in 5 years. So 2017 to 2022, when you have the third phase of solar mission, we expect a market size of almost $100 billion for solar in India. This I guess I can share with you. Okay, just looking at the typical cost structure for a solar power plant. We are, so this is the major component, the PV modules. It's about 60% of the total cost. Okay, inverter is the next largest component, about 10%. And the balance of system is about, the balance 30%. Okay. For CSP, the 30% is only the solar feed. Again, we're talking about only the mirrors and the stick. Then you have your storage, as you can see, is 12%. Yeah. Then balance of plant, civil works. Civil works includes cost incurred in the solar field also. So your overall cost of solar field, including the structures, the mirrors, and the civil works, would be about 60-65%, as I said. The power block and the associated areas would be about 35-40%. Solar PV, as I mentioned, it was about $400 a kg for polysilicon, which is down to about $50 per day. Wafer costs, dollar per watt basis, were about $2 a watt, which is down to less than 80 cents per day. The cell costs, $3 a watt, which is down to about $1 a watt. In fact, this is beginning of this year prices. Today's cells are actually below $1. Okay. Module prices are hitting close to about 1.3 today. Okay, from price of even $2 even last year. So you had a drop of more than 30% this year. And the same panels which used to cost $4 a watt are at 1/4 of the cost. So overall cost of a solar power plant, in fact in 2008, a typical plant used to, 1 megawatt plant used to cost almost 7 billion euros in Europe, which means you're talking about 30 crores. Not 30, 40 crores, sorry. Today that costs about 3 to 3.2 euros, so which means we're talking about 20 crores in Europe. In India, this can is the same, we can do it at much lower than 12. So there's a continued pricing pressure and cost projected to continue falling. In fact, module prices will probably settle at somewhere around 80 cents from the 1.2 levels you see in 2.5 years. So what will happen going forward is that this ratio is going to change. Even the inverter, which used to cost 30 euro cents a watt just 2 years ago, is today at about 12 to 15 cents. So even that's down to half, and that has scope to fall further. Inverter, again, the problem was a few European manufacturers monopolizing it, but technology is nothing great, so we expect those prices to come down. So with modular inverter prices coming down, what would happen is these two components will together shrink to about 40, 45 to 50% of the total cost, and the BOS as a percentage will grow larger. Now what happens with BOS is basically steel, which is your structures which are supporting the panels, your cement, which is the foundations on which those structures are installed, or the foundations for the control room and the buildings, etc. Then you're talking about copper, which is your cables, electrical cables, whether DC or AC, whichever cables you're using. These prices are never going to come down. Okay, they will keep going up. Okay, so your steel will keep getting more expensive, your copper will keep getting more expensive, your aluminium, your cement, all these prices will keep going up. So the cost of energy that you generate out of a solar plant is more and more going to get decided by this BOS components. And the less BOS you use, or the newer technologies that you use to make sure that the BOS cost is lower, is also going to be very important. So while the technology focus over the last 10 years has been on increasing the efficiency of the manufacturing side, okay, getting more efficient cells, using different kinds of materials. So more and more, the design of a solar PV power plant is going to become more and more important. Okay, and that's going to be critical. And the other thing that will also become more critical is that you have to use higher efficiency solar cells. Okay, which means that for a smaller size, same amount of energy from a smaller size panel. Okay, and a smaller size panel means lesser number of structures, lesser amount of land, lesser amount of steel, cement, copper, etc. Everything. Okay, so going forward, which is why we are confident that the thin film is going to fall back, and crystalline would dominate the market going forward as you see these costs becoming more significant. So how do we get to grid parity? So you have the cost per watt at module level, which was more or less driving the overall economics till maybe a couple of years ago. Today you have the cost per watt at system level, which is, as I was saying, the BOS and the module and the inverter, everything put together, which is more critical. And finally, of course, what matters most is the levelized cost of energy. That means what does each unit of energy that you produce cost? Okay. So current install cost, in Europe is about 3 euros, 3.2 euros. In US about $3.50 a watt. In India, as I said, it's about maybe $2.50 to $2.2 kind of levels. So if you see the cost of various types of energy, we are looking at wind is about 5 is probably outdated. It's about 3.5 to 4 rupees today. Solar thermal with storage is about 11 rupees. Solar PV was 12 rupees. This is about last year. This year probably it's slightly reversed. Solar PV is probably slightly less than solar thermal. Hydro is about 3 rupees per unit. Nuclear is about 7 rupees. Natural gas 4 rupees. Imported coal and domestic coal. So in India, you have plants which are running on domestic coal, but the shortage of domestic coal, so a lot of plants coming from coastal areas that imported coal. And imported coal is slightly more expensive. The cost of energy per unit is about 3.5 rupees probably. Okay. And the domestic coal-based plants are about 3 rupees. But going forward, what would happen is that all these items, the traditional energy sources, these prices will keep going up. Okay. Domestic coal, imported coal, whether it's gas, nuclear power probably won't increase in cost, but these prices will keep going up, whereas wind has scope to come down further. Hydro is of course probably stable. And we will have solar prices actually coming down. So what is important is when does this price come down enough so that it can match the other prices. So our expectation is probably your conventional costs are going to cross 5 rupees in the next 3 years probably. And if you have solar which is coming down to about maybe 8 rupees in the next 2 years. 8 rupees in the next 2 to 3 years. Okay. So we are expecting some, yeah.
Cost per unit.
Yeah, power, that's it.
Is it levelized?
This is levelized, that's right.
Then, the hydro and domestic coal cannot be same. So levelized hydro is much cheaper than coal.
Depends. Mini hydro would probably, this is only mini hydro, not
Small hydro.
only renewables. Large hydro you don't consider as renewable because of the environmental impact that it has.
They are renewable.
Yeah, but we don't club it in the same category. So what are the key components that determine the cost of electricity?
So why I doubted that figure?
Yeah.
Domestic coal. Average cost of escalation is 6% every year.
Yeah.
So that cannot compete with
No, that's what we are saying. This will go up. This will be more like static. That's what we are trying to say. This will come down. That's what we are down. This will keep going up. We expect domestic coal also to hit 5 rupees by 2015. Because shortages are huge. Coal India is not able to meet their commitments in terms of coal linkages which are there. So if you have a plant in UP which is running with 80% coal linkage, he is hardly delivering me 60% of what is promised. So I am dependent on again 40% of imported coal. So the blended price is going to keep going up.
First year the cost of generation is okay, but levelized tariff will always be
mini hydel turns out to be expensive. We are setting up a few plants in Northeast, 5 megawatt each capacity, Himachal and Sikkim, etc. Whereas
Small hydro in India is now up to 25.
correct, no, but we have set up 2 5 megawatt and 1 10 megawatt plant, and our finding is that the civil costs are so underestimated as of date. Our finding is that the cost of building a hydro plant is more than 7 crores a megawatt. If you're getting any hydro, depends on the terrain that you're in, but civil costs do tend, yeah, and that affects the cost. So this is just for you to understand, what goes into this levelized cost of energy and how this cost of energy per unit is calculated for solar. Okay. Now typically for solar you have a capital cost, which is the upfront investment that you make into building the solar power plant. After that your maintenance costs are very small. One is you have no fuel costs, okay, because you're not using only sunlight. And second is your maintenance is restricted to basically, as I said, cleaning the panels, ensuring that the electrical connections are maintained, etc. CRC says about 9 lakhs megawatts should be sufficient per year for maintaining a solar power plant. And our estimate is somewhere around 7, maybe 6 to 7 lakhs should be probably sufficient. And but anyway, so basically it's capital cost which decides the cost of electricity. After how does the capital cost translate into cost of electricity? It's basically your repayment of the term loan that you take. Every year you would have to generate enough cash to repay the term loan, which gets covered by a depreciation of your plant. And the second component is the interest, okay, which is the interest that you have to pay. So your interest plus repayment, which is typically, so if you're taking a plant of say 10 crores a megawatt, if you're down to 10 crores a megawatt, you can expect your annual repayment obligation to be somewhere around 20% of that. Interest plus principal put together, depending on the tenor of your loan, etc. So key things for solar to determine the cost is one, the initial capital cost, second is your financing. Okay, so financing is absolutely critical. Okay, the reason why we are not as large a market as Europe and we will struggle to grow today is that in Europe it's possible to get financing for a solar power plant at terms of even up to 85-15. Okay, which means you 15% equity, 85% debt. So which means larger leverage is allowed. Your repayment can be anywhere between 15 to 20 years. Okay, which means you're allowed to repay a loan over the 15 to 20 years. So if you're taking 85% loan and you're allowed to repay that over 15 years, only 6% of the capital cost is becoming a burden for you in terms of annual repayment. And your interest cost again is only 4 to 5%. Okay, so overall burden for a European power plant in terms of what percentage of capital costs you have to generate to pay every year is 10% or 11%. Okay, India it is 14% interest today, 13% interest. Plus repayment over 10 years which add another 10%, so you get 23% of capital cost. Okay. So even if my capital costs are lower, my cost of electricity is going to be higher than that. So that's the issue that we face today. So financing is a critical thing for solar projects going forward. Yeah. So this left side, what you see is your typical CERC model and the key assumptions that are going into calculating the levelized cost of electricity. So CERC last year, the order that they came out with, they said project cost of 14.42 crores a megawatt, and the levelized tariff that they came out with was 15.39. And the key assumptions for that is that debt is 70%, equity is 30%, which is not a major problem. So even then, developers are finding it challenging. There are banks which are insisting on 2:1 debt equity ratio, which means 65-35. If you change it to 2:1 again, the cost of levelized cost of electricity will go up. Okay, so 2:1, then we are looking at interest rate. What CRC is assumed is 13.25, which is more or less what is in the market today. So your depreciation rate of 5.28 is an attempt to recover the 70% over a period of 10 years. Yeah, first 10 years, so you are doing 7% depreciation, which is assuming that your repayment is over 10 years. 70% debt, so 7% per year is the depreciation. And the next 15 years, the balance value of the plant is getting depreciated. So with the system life of 25 years and your CEO of 19%, which actually translates about 1.66 million units per year for 1 megawatt plant, you are getting a levelized tariff of 15.39. Okay. Right side, what happens if your financing is slightly better? Okay. Assume you can get debt at 80%. Okay. Assume you can get special financing, which is either ECBs or slightly maybe export credit agencies from the US or ECA finance or slightly subsidized financing from the government. Assume 9% interest rate. Okay, and assume a 15-year repayment period. Okay. Now what happens is your depreciation for the first 15 years comes down to 5.33% first of all. Okay. Interest rate is down to 9%. Everything else is the same. No other change in assumptions. Okay. With just changing the financing terms will reduce your levelized tariff to level rupees 75.
Sir,
Yeah.
why are you not considering accelerated depreciation?
No, accelerated depreciation is more or less getting reformed. It is there today. So today what happens is for a Gujarat power plant, accelerated depreciation is allowed. For projects under the National Solar Mission, basically CRCs come out with two tariffs. One is with accelerated depreciation benefit, other is without accelerated depreciation benefit. Most of the PPAs and allocations which have happened under the National Solar Mission are without accelerated depreciation. So this 15.39 is without accelerated depreciation. If you consider accelerated depreciation, then your tariff comes out by 2.5 rupees. Okay. Yeah. The models are available on the CRC website. The entire tariff order, the model which they've used, the spreadsheets, etc. Those are available. So any of you can download at any time, try changing these numbers and see what happens. Okay. But basically, point I'm trying to make here is that financing is a critical part of your entire cost. Okay. And going forward, who can finance the projects better is going to decide who's going to lead the market. This is a levelized cost sort of graph. Okay. So grid parity, we are talking about anywhere between 2019 to 20 is what came out recently, KPMG report. Okay. What is their projection? Our projection somewhere around maybe 2015, 2016. This is where we expect this to happen. We are there in both sectors, so we have fairly good idea of what's happening in both cases. So what is going to happen with conventional power prices and what's going to happen with solar prices. So we would expect this to happen much faster than this. Yeah. So basically, there is a lot of potential in terms of insulation. There's a support from the government in terms of National Solar Mission. I mean, there was nothing happening in the country until 2009. And then 2010, they come out of the solar mission and they've gone on pretty seriously, at least with phase 1. So, and we see a lot of good things which are happening from the regulatory side and the government policy side. Okay. There's a lot of opportunity also in the operate segment, so I'm not going to detail that. Basically, in the operate segment, we're talking about one is your telecom towers. Okay. There are more than lakhs and lakhs of telecom towers, and many of them are in remote areas. So there's at least a potential of at least 2,000 to 3,000 megawatt capacity in providing supply to telecom towers which are in remote areas, which are today running on DG sets. Okay. Now your typical DG power costs anywhere between 12 to 14 rupees a unit today. Okay. So solar is already at parity with that. So it's only a question of reaching out there and finding the money to make the investment. Okay. Other than telecom towers, we also have rural electrification. Today, government has has a policy that there should be at least one light in every household in every village. So they are spending a lot of money actually taking your transmission infrastructure to remote villages just to make sure that they receive that power. Okay. And instead of taking the transmission money that you're spending on the transmission infrastructure, if you actually spend on solar, setting up a mini grid within the village, it might turn out to be cheaper. Okay. Challenge with the off-grid segment today, which are not touched upon probably in detail, is that when you're not on the grid, you have this necessity to store your energy. And we discussed in solar thermal, it's possible to do heat storage, thermal storage. Whereas with solar PV, you have to store the electricity and you have to store it in batteries. Now that today is a very expensive proposition. Okay, because when you have to store in batteries, you have discharge losses for the batteries, and typically you lose another 20% of your energy by the time you put it into a battery and take it out. Okay, and that takes up the cost of your energy. So if you're getting electricity in your house at 5.5 to 6 rupees, you store it in your inverter and you use it when there's electricity cut. Okay, that energy is actually costing close to 11 rupees because of the losses that you face in the inverter and the batteries. Okay. And batteries don't have a long life, they need to be replaced, they need to be maintained 2 to 3 years maximum. So these are the challenges which are there in the operate segment. For grid connected, as I've already explained in detail. So these are things we need to get sorted out. So many issues, going next 10 years, one, as I said, the design of the solar power plant and using technologies to generate more CO is going to be important. Second thing is going to be storage. Storage is going to be key to even the grid management. So even for large grid connected plants, so like in Europe, especially Germany, they're looking at possibilities of storage at the substation. Okay, so solar energy gets generated. You would have excess energy at some points, and you will of course a shortage when the sunlight is not good. So store energy at the substation, use it to feed it back into the grid when the energy generation is not good. So storage smart grid, and of course the overall design development of the farm. These are going to be three critical factors over the next 5 to 6 years as far as development of the entire market goes. Right, thank you.
Thank you, sir. I'm Sandeep. I'm second year student.
Yes.
The question is not related to solar. My question is related to career role model.
Okay.
Sir, as a management student, we are going to join energy sector.
Okay.
So, what kind of attitude or approach one should have as a management student starting his career in energy? Or could you share your own success story?
My own success story. Let me see. 14 years before 2008, I was in the finance sector. Okay. I got into renewables only in 2008. I have a little exposure in the power sector. But basically, going forward, I think it's important that you choose the right sector, even within energy. Frankly, I'm pretty sure that renewables is going to be the main growth area. Whereas, of course, in India, energy itself has a huge potential because our shortages are. While the government says there's a 10% energy shortage, if you see 40% of households in the country don't receive any electricity at all. And if they start receiving electricity, the shortage is going to be much higher. So the kind of capacity issue that we're going to see in this country over the next 10 years, both conventional and renewable are going to be very large. Renewable has a greater potential to give an international exposure, okay? Because unless you understand the international markets, you're not going to understand the sector at all, because that's where most of the market is. But going forward, I think, as I said, key is to understand as a management student, one is financing, regulatory, okay, because regulatory is a key in the power sector in India today, whether it's going to be solar, renewables, or even conventional. The regulatory scenario, the financing, and technology. These three areas are what you need to keep focused on. Yeah.
Sir, you are the developer of solar power plants. What barriers, what obstacles you find based on the policies which are present in India, like NSM, or whether in Gujarat solar policy or in Rajasthan solar policy,
or REC,
or maybe REC.
RECs, okay. RECs, as it stands today, is a big challenge. Okay, let me start with that. We talked about RPOs earlier. How does RPO work? Okay. Not every state will have the same potential to generate solar power. Today, Gujarat and Rajasthan will have much better potential than any other part of the country, except maybe small parts of Andhra Pradesh, Tamil Nadu, etc., to generate solar electricity at a cheaper rate than because of the extra insulation. Okay. So you are finding that most of the capacity that's coming up today is coming up in these two states. Whereas all the other states will also have their RPO obligations. So to meet the RPO obligations, you have this REC mechanism. So any state which has surplus electricity or any utility which is buying extra solar energy can then have these RECs which get sent to state which is short of solar energy. Okay. So REC is supposed to freely tradable. Now the only problem today as a developer for me to set up a plan based on REC is that solar tariffs will keep coming down, and the REC prices are linked to the tariff. There is a floor and there's a floor and a forbearance which is declared every year. Whereas if I set up a power plant today based on a PPA, which is under the NSM or the Gujarat solar policy, I have a 25-year PPA where the tariff is fixed. Okay. If I set up a plant under REC, I'm required to sell the energy at the average procurement price of the utility to whichever is the local utility. And the balance money I'll make out of RECs, which price will keep coming down. Okay. So since I don't have visibility of what is the money I'm going to make out of these RECs going forward for the entire 25 years, I cannot get the project financed. Okay. That's the issue that we face today with REC. So while the government is very gung-ho about it, there are no projects which are actually coming out which are to be set up based on REC. So people keep talking about it. One of the things that CRC is trying to do is that they are going to make a change in the regulation probably. They're discussing this. This is a discussion stage that each year as the REC price keeps coming down, as the floor of the forbearance keeps coming down, they will decide that the plants which are set up in earlier years should receive more RECs. Okay, for the same amount of energy. Okay. So they will decide the ratio of this extra RECs based on the price which is prevalent in each year. So that as far as the old plants are concerned, they get the same revenue stream across all the 25 years. Now if that happens, then this will take off. Okay. Until then it's a bit of a challenge. That's one part as regards REC is concerned. even the cases where the PPAs are there, one of the issues that we typically face when we go to financiers is, how strong is the PPA? The worry that they have, and which is probably well founded, is that you are selling what is really expensive power. Okay. And today there must be a government, there may be a government in the state which says, okay, I'm ready to buy the expensive power. 3-4 years later, suppose the government changes. Okay. Typically, scenario in India is to revisit everything that the previous government has done. So if you have expensive power, there's always a possibility, at some point the utility might decide, or the government might decide to break the PPA. Okay. So that's one risk that you always run in terms of the PPA, the chance that because it's expensive, and also because solar power cost itself will keep coming down. Okay. So 5 years later, the same utility can buy the same solar power from another developer at a much cheaper price. Okay. So these are the uncertainties that you have today. In fact, that's not just in today. When we say in Europe these things don't happen, Spain is actually revisiting, thinking, or at least talking. There were substantial discussions in the parliament to reduce the tariff retrospectively for plants which are already set up, because of the issues that they are having in terms of government deficits, etc. So these things, so political risk in terms of the PPA risk is always there. That's one part. And the last part is, of course, minor things, like land. Okay. And land is a key factor for solar because you're using almost 4 or 5 acres of megawatt. So if I want to sell a 50 megawatt plant, it's 250 acres. So any conventional power plant also has land acquisition problem. Solar is a bit more because our land per megawatt is higher. Okay. So and with now this land acquisition, political climate in the country is also changing. We have the new land acquisition bill which is coming in. So that going forward, we expect this to be a challenge. Okay. So land is going to be a little bit scarce resource. So that's one problem. Second is approvals wise, there were issues in terms of things like environmental clearance, pollution clearance were being asked for even for solar plants. Okay. Because there are not too many plants in the country and the pollution control boards are not aware of solar plants also. So they were insisting on these kinds of things. But those are changing now. So those are getting better. Other issue is infrastructure in terms of grid infrastructure. Okay. So while there's excellent potential out in the Rajasthan desert areas we are setting up most of our plants at Rajasthan out in Jaisalmer district. It's about 40-45 kilometers from the Pakistan border. Excellent area in terms of installation. The problem grid infrastructure is not there. So my nearest grid substation is 55 kilometers away. To build a line to evacuate the power to that level, those are additional expenses which sometimes you don't build into your project cost. Can add substantially to your costs, these kind of things. So grid infrastructure in these areas is something that the government is working on. In fact, Rajasthan itself has a 2,000 crore plan just to build up the transmission infrastructure in these areas, so that more renewable energy projects can come out. Yeah.
So regarding financing, why can't Lanco get loan from some other countries, sir? Like Reliance got a loan from Chinese bank at 2.5%.
Those are typically export credit agencies. Okay, so Reliance is importing some Chinese equipment, they will get financing and all that. Typically what you find is that, so if you're importing a panels from a particular country, like if I'm importing solar panels from US, I can probably get US Exim Bank financing, which is cheaper. So that comes at a rate which is typically about 1.5-2% less than the ECB rate. If I'm not importing this equipment, if I'm using my own manufactured equipment, I can't get this export credit agencies finance. So then it comes to ECBs. Now, ECBs typically I can get at about 4.5-5%. But problem is when you add hedging cost to that. Now all my revenues are going to come in rupees. I'm setting a power plant for next 25 years, I'm going to get my revenues in rupees. If I have 10-12 years financing, which is going to be in dollar or some other currency, then I need to hedge it for the 10-12 years to make sure that I don't take a risk on the currency fluctuation. If you had hedging cost, it comes back to same 10-11%.
But in India it's 13.25.
Yeah, so 13.25 is also today what happens in India is that you have seen interest rates going up over the last 3 years. Okay. And what we expect is going to peak out at some level. Growth is already slowing down, or we will start cutting rates. So again, it will come down. So your average rate in India would probably be around 11% range. It would be. If you see in 2003, 97, it was at 80-90% interest rates. You had 80-90%. By the time you had 2002-2003, it was down to about 7%. Okay. Today it's back to 14%. It will come down again. This is a cycle which will go through. But if we over a 25-year life of the plant, it should even out. You should end up at about 10. I don't think more than that.
Wind farms have a lot of space.
integrate. Typically, in wind farms, what happens is most of it is agricultural land. So whatever space is getting used for agriculture. Okay, I can acquire that land and start putting solar panels there. Only thing I need to be careful about is the shadow. I can't have the shadow of the turbine falling on the panels. So that creates a bit of a limitation. The turbine and the blades both can create substantial shadow. Right. But we are looking at those possibilities. To the extent possible, it makes sense to utilize that. But that's not unused land. Typically, wind farms buy only the area required for putting up the foundation. Okay, so they buy only that area, and then you have some significant span between the next turbine with the next turbine. So land in between continues to be used for agriculture. Hills have their own challenges in the sense that putting up those solar panels is not so easy. So it can be done. But again, I need the panels to be facing south because typically that's where the sun is. Okay. So I can use only one side of it. There's a slope. There's only one side of the slope that I can use. I can't use both. Anything else?
Sir, you set up a polyps line manufacturing facility, and going forward you're looking at this line PV technology.
Yeah.
How in this and which has a negative temperature versus efficiency coefficient. So how do you look at a hybrid of solar and solar PV and thermal in this regard?
Hybrid of solar PV and thermal.
Yes, sir. A couple of days back, we had an expert coming in from SEC who introduced us to this idea. What happens is that a PV panel has a coolant pipe going through it, which gets heated up as the panel gets heated up because all the light is not being absorbed or converted into power. So that
keeps the temperature low and also gives you some extra energy for.
Yeah, the figure that he quoted was 12% increase in efficiency from round about 12-14% to round about.
This is something that people are working on. There's one more technology in PV which is called concentrated PV. Okay, now typically what happens in this technology is that you use a little amount of silicon. Then you use lenses to focus the light on that silicon, so the amount of light which is falling goes up exponentially. Okay, so with the less amount of silicon you're able to get the same amount of capacity. There again you have the same problem of temperatures going up very high. Yeah, and it's different. What you're saying is different. I'll come back to that. So what happens in CPV is the same problem, which is because more light getting focused, your temperatures go up very high. Again, the crystalline efficiency falls. So you have coolant which is passing through, or you have air cooling or wet cooling, which is to keep the temperature down. No, that part is fine. Okay, it's a bit expensive right now, which is why CPV is not taking off. But we expect that going forward, yeah, if some breakthrough happens on that portion, CPV might become significant. Today it's not very significant. What you are saying in effect is that use this liquid, which is used as a coolant, to generate steam. Only problem is that it gets heated up only to about 60, 65, 70 degrees. So you can use it for process heat. Now thermal as a process heat application would take off substantially is what we believe. Which means in factories and other applications where you need 70 food processing industry, textile industry, etc. If you need 70, 80 degrees centigrade water, you're using it anyway in your households, for your heaters. Yeah.
I was not talking about using it for generating steam. I was talking about
just cooling for improving efficiency.
Combining some application which requires heating along with the PV.
So that main application process heat. Okay, you can't use it to generate steam. That's what I'm going to say. So process heat applications where you require 70, 80 degrees water, probably that kind of thing can be combined. So you could have a panel on your factory rooftop, which could then also generate some hot water for the other applications. Or you could have it in your household rooftop also, where you could use the hot water for your personal use and generate electricity at the same time. But not much happening on that space as of now.
Yes, sir.
Depends on how the cost works. Finally, it all boils down to cost per unit. Yeah.
So is there no way where the molten salt that's actually heated up can be actually transported from like a solar farm to some other place where you don't have a solar farm? So can it not be a portable one? Like not portable, but a big one where it can be actually transported, something like that, where people can use solar farm, maybe, off-grid or something like that.
Not possible.
But what issues?
Like for example, my 100 megawatt plant for 4 hours storage, I think I'll be using something like 40,000 tons plus of salt. Okay. Transporting it and no, but the point is you will have problems with your insulation. I mean, having a tank and that kind of volume, handling that volume, and having that insulated tank which will be set on a large foundation. So transporting it won't be one.
Maybe later on we can actually
or if you have to transport across long distances, I think transporting energy is easier. Storing energy, storing electricity and transporting is probably easier. Yeah.
So I understand each wafer responds to a particular type of wavelength.
Yeah.
So can you have a model wherein there is a combination of monocrystalline and polycrystalline, or mono with cadmium chloride?
There are what are known as hybrid cells. In fact, Sanyo makes them commercially. They have a cell which is called a hit cell, which is a combination of thin film and crystalline. It's a sort of a sandwich between it's a 3-layer structure, 2 layers. I think 1 layer of crystalline, 2 layers of thin film. And that gives efficiencies of about 21%, primarily because it is able to absorb these different spectrums of light. Okay. So that makes a difference. Yeah, it's there already, and people are working on it. And so also available commercially. Again, cost is a bit high. That's the issue with. But Sanyo one is fairly successful. High efficiency, but slightly more expensive.
Sir, we are talking about we can store the solar energy. We don't have any technology.
We do have technology. They are not efficient. Efficient and
Can we go for hydrogen and like
fuel cells.
We can spill water into hydrogen. That hydrogen we can use in any time, anywhere. So why don't we have
Can be done. Typically can be done. No problem. Fuel cells is like a battery, so that can be done. Again, fuel cells are expensive. So as I said, storage is going to be key. That's something that we are also looking at very keen, because you need to develop those applications to make sure that PV takes up in a big way. I mean, 1%, 2%, 3% of the grid is fine, but if you want to be 20% of the grid, you can't handle that kind of fluctuations in energy. In fact, last year there was a case in Germany, there was a large amount of wind capacity also, in fact, whole of Europe. And most of them have a common grid. Last year there was a case where one day suddenly 19 gigawatts